Topic 2 overview, looking at galvanic cells in 3 minutes. Firstly, galvanic cells are based on redox chemistry, so before you start to look and tackle galvanic cells, you need to make sure you know your basic redox. Oil rig, the oxidation numbers, you need to be able to assign and use oxidation numbers. You need to balance half equations and utilize the electrochemical series. Once you've got your redox foundations down pat, you then need to apply that to galvanic cells. The key features of a galvanic cell are a couple of electrodes, an anode and a cathode, half equations occurring at those electrodes, and a salt bridge which kind of separates the electrodes to make sure the electrons don't just simply jump from one thing to the next, they get forced through a wire. You need to understand the electrode properties, so the fact that electrodes are designed to actually make the reaction occur as best as it possibly can. So they might be porous to increase surface area, or they might be catalytic to lower the activation energy and ensure our rate of reaction is enough to sustain the electric current that we want to produce. Galvanic cells can be divided into a number of different systems. So you got a primary cell, a secondary cell, or two types of fuel cells here. Primary cells are disposable, they're a one-trick pony basically. Secondary cells can be recharged, and fuel cells, they have external reactants being pumped into them so they'll continuously work provided you provide that fuel. The fuel cells, as you can see here, I've divided up into two sections. You need to know the hydrogen fuel cell really well, but you also need to understand about organic fuel cells. Most of the stuff here is the same, and the basic principles of galvanic cells, such as oxidation of the anode, reduction of the cathode, electrons flow towards the cathode and whatnot, all that's the same for both hydrogen and organic fuel cells. The difference is with hydrogen, you are reacting hydrogen at the anode and oxygen at the cathode. The overall reaction for a hydrogen fuel cell is hydrogen reacting with oxygen to produce water, which means it's really good for the environment. You're not going to produce any carbon dioxide. You have to understand what the reactions occurring in the hydrogen fuel cell are and identify if it's going to be in acidic or alkaline conditions. With organic fuel cells, again, the fuel enters the anode, but this could be any organic compound. You can have an ethanol fuel cell, methanol fuel cell, or whatever type of fuel cell. But the fuel is always going at the anode and it's going to be oxidized there. The fuel is going to be turned into carbon dioxide in an organic fuel cell, which means that the overall reaction for our organic fuel cell is going to be the same as the combustion reaction because our fuel is at the anode and oxygen is going to be present at the cathode, considering that this will be an organic / or a fuel air fuel cell. You should be able to list a number of pros and cons for using fuel cells and compare the use of fuel cells to that of combustion and getting energy from burning a fuel instead. Again, I've run out of time to talk about my top tips, but read them here and make sure you understand the fundamentals of redox reaction.